my name is SAMPATH. Today I am discussing about real numbers, which is your first chapter. Anyone who know about real numbers? We have learned about this in 9th standard. Then say, what is it? Real numbers, the numbers which total comes in mathematics are known as real numbers. In real numbers, we can see two types of numbers. First one is, which is first one? Rational numbers. And second one is irrational number. What is meant by rational number? Anyway.
The number which can be written in the form of p by q.
That's good. So, rational numbers are the numbers which can be converted in form of p by q. For example, 2. We can write 2 in fraction. Yes or no?
Yes.
Like this, no? Yes. And what are the irrational numbers? Numbers are the numbers which can't be come in form of p by q. They can't be written in form of p by q. For example, 1.0231667 so on, which can't be written in form of p by q. And take one example, 1.666. Is it rational number? So on. Is it rational number or irrational number? No. Next, an example of irrational number in roots. Do you know the prime rooted numbers? Prime rooted numbers. Example, root 2, root 3, root 5, which are always in irrational numbers because they hadn't any definite value. They come like this, 1.022 so on. So they can be termed as irrational number. But root 4 is a rational number. Why? Because its value is 2 and 2 can be written in form of p by q. So there is its 2 by 1. And after that, next point. Next part which is not in your syllabus. For introduction of real numbers, we can have to explain it. So there are some numbers, positive integers and negative integers. First one, positive integers. What is meant by positive integers? The numbers which are greater than 0 are known as positive integers. For example, 1, 2, 3, so on, up to infinity. And second one point is negative integers. What are negative integers? Anyone?
The numbers which are less than 0.
Good. Anyone can say its examples? Good. -1, -2, -3. It's the positive integer always be greater than 0 and negative integers always smaller than or lesser than 0. Okay, clear? Any doubts? Then 0 integer. Oh, positive or negative integer?
Positive.
It's a constant. About prime numbers and composite numbers. Right? First, positive numbers.
Sure.
Anyone who can say about prime numbers? Positive numbers, the numbers which had factors of 1 and its own number. For example, there is a number, for example 23. It can be said as prime number. Why? Because it has factors of 1 and its self number, which is 23 only. Hence it is known as prime numbers. Clear? And there are the examples for prime numbers are 2, 3, 5, 7, 11, 13, so on. Up to infinity. There are prime numbers. And next point, composite numbers. What is mean by composite numbers?
The number which has two or more multiples, it is called composite.
Good. See. Composite numbers means the number which had more than 2 factors. For example, there is a number which is 10. 10 had factor 2, 5 and 10 and 1. 1, 2, 5, 10 are the factors of 10. Hence it is known as composite numbers. Clear? Any doubt? 2. Correct. And which is smallest composite number?
4.
Good. 4. 1. Is 1 prime number or a composite number? No. 1 is neither prime nor composite because it had only one factor. One's factor is only 1. Hence, we can't say it is a prime number and it is a composite number. Hence, we can call it as a neutral or a common number which comes in all composite number and prime numbers. Okay. Next point, the fundamental theorem of arithmetic. In your second page of your textbook, they are given one point. Fundamental theorem of arithmetic. Can anyone define the fundamental theorem of arithmetic? Anyone? Girls? Fundamental theorem of arithmetic. Anyone?
Every composite number is the product of prime number.
And this factorization is clear. Good. Fundamental theorem of arithmetic. Arithmetic says that every composite number. What is composite number? Which had factor more than 2. And that composite numbers can be factorized. Unique then the factors come then other numbers. That this statement says that every composite number can be expressed as product its prime factor. Like that, take an example for 50. Its factors are 2, 20, 5, 5, 5, 5. The fundamental theorem of arithmetic says that 50's factors are 2 into 5 into 5. That is the normal factorization. But the fundamental theorem of arithmetic says that this can be written as 2 into 5 square. I have taken square here. Due to 2, 5. Hence we are 5 square. This is the method which is said by fundamental theorem of arithmetic. And next point, example for this factorization, take 10. Anyone can solve this? Come on. Anyone? Boys? Abhishek? Sorry. Good. Then we can see that factors of 10 are 2 and 5. Then 10 can be written as 2 into 5. So in your examinations they do not ask as much as easier than this. They can ask more than 2-digit numbers for 2 marks. And take another example for it. 20. You take 20, and the factors of 20 are 2 into 10, 2 into 5, 5 into 1. Then factors of 20 are 2 into 2 into 5. We can be write this as 2 square into 5. This is very easy, no? You can take up to 1 to 2 marks in your examinations. So let's move on next topic.
Go LCM and HCF.
Yes. First one, LCM. LCM means least common multiple. And everyone know how to take LCM? We have studied in 5th standard. Since from 5th standard. LCM, which is meant by least common multiple. Take example for 2 and 5. Here we take LCM as the factorization method, which we have done previously. Take 2 separately and 5 separate. Take its factor. 2 ones are 5 ones are. Here write 2 and its factor, which is 2. Here 5. This factor is 5. Then LCM. How to take LCM from this is LCM is equal to, here any same numbers? No. Take both numbers. 2 into 5. Then LCM is 10. Switch on. Let's even the other example. 36 24. So factors of 36, 2 ones are, 2 eights are, 2 nines are, 3 threes are, 3 ones are, and this is 24. 2 ones are, 2 twos are, 2 sixes are, 2 threes are, 3 ones are. Then factors of 36 we have to write here. Factors of 36 are 2 into 2 into 3 into 3. Factors of 24? 2 into 2 into 2 into 3. 3. Then write this in the fundamental theorem of arithmetic manner. Like 2 square into 3 square. And this 2 cube into 3. And here in LCM, 2 is common. Which power is more? 3. Then take 2 raised to 2 power 3 into, and here 3 are common. Which power you take, this or this? Upper side? Yes. Good. Then 2 cube is equal to 8 into 3 square is equal to 9 8s are 72. So this is the LCM of 36 and 24. LCM. Here 2 are common. Which has smallest power? 2. 2 square into, and here 3 is common. Which has smallest power? Down. So 3. 2 square? 4. Into 3. 4 3s are 12. This is 2 marks question which is asked in your board examinations. Here in your textbook, they have given one relation about LCM and LCF. They are given that A is the number, first number, which is 36, and B, which is 24, second number. So A into B is equal to LCM of AB. LCM of AB into HCF of AB. Correct?
Multiple.
What is the value of A? 36 into value of B? 24. And value of LCM? 72. Value of HCF? 12. Then multiply 36 into 24, how much? Fast. 204.
2.
864. 864. Then 72 into 12. 864. Then both are similar. LHS is equal to RHS. So this relation is correct. And in your examinations, they can give A value, B value and LCM value. They ask you to find out the HCF. How will you to find out the HCF? Anyone? Formula to find HCF by this relation? Anyone? A into B divided by LCM. Good. Here the HCF or LCM, we have to find LCM. Then HCF keep here and LCM come into left hand side, which multiply with here is multiplication, no? It becomes divided by A into B. Then we have to put this formula to find HCF if they given 3 elements. Okay? Next one, they give A value, B value, and they ask you to find the LCM, and they have given HCF value. Then what will you do? LCM is equal to A into B divided by LCM. Good. Similarly, they have given the value of B, LCM and LCF. They ask you to find the value of A. Then formula to find A, LCM into LCF divided by B. Correct. Similarly, to find the value of B, they have given A, LCM and LCF. LCM into LCM divided by A. Good. Cleared? And another one question, they will ask for about 3 marks. They have given A value and B value. Okay? But they didn't give HCF value. You have to first find the value of HCF. After that, apply this formula relation. Because they have asked you to find the value of LCM by using this relation. Can I give example for it? Let's take A is equal to 10, B is equal to 15. They hadn't given LCF as well as LCM also, but they are asked to find the value of LCM by using this relation. If you did the last one method by applying the factorization method, they do not give you full marks because you do not use this relation. So first find out the HCF. 10 2 5 5 1 10 is equal to 2 into 5. After that 15 3 1s are 15 is equal to 3 into 5. HCF is equal to which are common numbers? 5. So power 1 only. No? So take 5 only. HCF is 5. And we know this A is equal to 10, B is equal to 15. And we recently know about that HCF which is 5. So apply this formula A into B. 15 into A is equal to 10 into B is equal to 15. LCM we don't know about LCM. LCF is 5. So LCM is equal to 10 into 15 divided by 5. Here 5 which divides 10 into 15. So 5 ones are 5 twos are 15 twos are 30. The value of LCM is 30. Let's see here what is the value of LCM, which is common. 5 is common in LCM. Take 5 only 1 unit, and here 2 into 2, and here is 3 into 3. 3 twos are 6. 6 5s are 30. Is it correct? This is 30. 0 and 2. 0. Correct answer. 2 into 3 into 5 into 7 plus 5. Is it prime or composite? Composite. Why? Because which is common? 5 is common. Take 5 as common. 2 into 3 into 7 plus 1. Here we get 5 as common. Hence it is a composite number. Clear?
Yes.
Any doubt? Let's move to next point, which are given in your second exercise, which is prove that root 2 is an irrational number. At first, we have to assume that root 2 as a rational or irrational? Rational number. Rational number. And here it is rational number. We have assumed that root 2 is rational number. Then root 2 is equal to P by Q. And P and Q are co-prime numbers. What is meant by co-prime numbers? Co-prime numbers?
That are written as P by Q form.
No. Anyone? No? Co are the numbers which had HCF only one. That numbers are called as co-prime numbers. Under co-prime numbers andra hatrdu highest common factor ಏನು ಇರ್ತೈತಲ್ಲ 1 ಇರ್ತೈತಿ. ಅವಕ್ಕ co-prime numbers ಅಂತ ಹೇಳ್ತೀವಿ. P and Q are co-prime numbers. Co-prime numbers. And then shift this Q to here. Q is divided. Then here it is multiplied by root 2. Q root 2 is equal to P. Squaring on both sides. Squaring on both sides. Then put bracket square. Root 2 squared, then comes value is 2. Here root 2 square means root 2 into root 2. Root 2 into root 2 is value 4. Root 4 is nothing but 2. Here take 2 and this is q square. This square is applied for this both q and root 2. Hence I have taken 2q square and here p square. And here this 2 will divide p square. Q square is equal to p square divided by 2. There is another theorem you will get know about this. That theorem says that when a number, then 4 square is equal to p into q, p into 2. That 4 square is also divided by 2, and that 4, then 4 square is divisible by 2. 4 square is equal to 16. 2 ones are 2 eights are, and here 4. We have taken that q square and after that q, no? 4 which is also divided by 2. Let's see here, 4 is divided by 2 or not? 2 ones are 2 twos are. Hence we take that p square is divisible by divisible by 2. And also that theorem says p is also divisible by 2. Then take the p as constant, p as 2k. K is known as constant. Constant means whichever number we can take, but we don't know the definite number, so we taken a k as constant, 2k. Here 2k, the 2k value is shifted from p whole square. Then 2q square, here 2 square 4, k square divided by 2. 2 ones are 2 twos are. Here 2 which divides q square. Like that, similarly here q square is divisible by here q square is divisible by 2. Q square is divisible by 2, and q is also divisible by 2. Hence the both are divisible by 2. q and p are divisible by 2. Then its HCF is 2. Then both are divisible by 2. Then their HCF is 2. This confusion is occurred because here we told that p and q are co-prime numbers which HCF is 1, and here the HCF came 2 because root 2 is an irrational. ठीक है